This sturgeon, which is a very large fish species, used to have a range quite far across, spread out across Europe, but more recently they've become extinct along much of its previous range due to restrictions of river sections and river developments and things such as dams. So really we have some last key strongholds, one of which is in Romania or around the Black Sea with the Danube River and the Danube Delta, which is where our partners in Nature First, DD&I, are doing a lot of their work. So essentially, the beluga sturgeon will spend most of its life in the Black Sea and will travel up the Danube River during seasonal migration. So they will enter the river sometimes in winter, but the most important time perhaps is this spawning migration that happens in spring. And during that time, they're also very vulnerable to poaching. Poachers will target sturgeon for their eggs. I'm sure many of you are familiar with caviar, and specifically beluga caviar is highly expensive and therefore a very profitable thing for these poachers. So the aim of Nature First working with DD&I is to essentially work together to help monitor this critically endangered species, and through this monitoring to better strategize for conservation. So our journey kind of begins back all the way in June 2023, when I first visited Tulcea, where DD&I work, which is around the Danube Delta. And the question that I had when I went was, how do we leverage the information we have to aid monitoring and conservation? So in order to answer that question, I met up with the sturgeon team and other members of DD&I to understand how they operate in this system, what kind of data they have, and what expertise is there, and how I could potentially develop a tool which could help them in this monitoring and conservation. So what I came away with was an understanding that for the beluga sturgeon, there are some very important key events that happen during the year. As I mentioned before, this sort of migration into the river, into the Danube River, is a key focus, not only because they will spawn upstream in the river, the eggs will hatch, and then the young of the year will travel downstream, but also because they are vulnerable to poaching during this time. And a second impact of this is that we can also harness that for scientific fishing. So when the sturgeon are in the river, that's when scientific fishing occurs. So the key scientific fishing that occurs and where we get really most of the data and the most reliable and longest source of data about the beluga sturgeon in this region is from monitoring these young of the year. So that's the sturgeon which have just hatched in this year from the spawning season, and they're making their way downstream out to the Black Sea. So we know that we have this young of the year, we have a catch, and we know how many beluga sturgeon were caught year on year. But what we don't know is whether we can also link an increasing number of young of the year caught, decreasing or stable, to a similar population trend in adults. So essentially, can it be used to monitor adult population? So these are some key questions and events which we're going to use going forward. So from all of this knowledge, I started to develop an agent-based model of beluga sturgeon, both to simulate theoretical population dynamics, which I'll explain later can help us to understand and answer the question of, does young of the year catch relate to adult population dynamics and can be used for monitoring those? And also, perhaps more importantly, simulating these real migration patterns based on real environmental data, which can help strategize monitoring and potentially later be used for prevention and increased control from poaching. So first of all, what is an agent-based model? So the most important part is in the name, the agents. So agent-based models contain these so-called agents, which can be a little bit difficult to define. But essentially, each agent in the model has a set of rules that it uses to make decisions. So in our model, our agents are sturgeon, and in the yellow box, we can see the agents in the model are split into classes that determine their life stage. So we have adult agents, we have subadult agents, and we also have groups of eggs that are agents as well. And each of the agents in the model will make a decision, for example, whether they would start migrating based on a set of rules, such as are they an adult or what is the environmental conditions or temperature. So the idea from an agent-based model is that all of these individual decisions that agents are making within the model combine to create this population level pattern. So we can understand, for example, when we might expect most of the population to be spawning. In most agent-based models, there's really a lot of theory, but in our agent-based model, we have it based on real environmental data. This environmental data is collected at data collection stations along the Danube River, and they collect water temperature and water level measurements each day. So they have daily information. And this data stretches back quite a long time. And for this scientific use of the agent-based model and the questions we address, essentially, this model simulates every day over an 8-year period. So it's really quite a lot of time that we're using in this model. So when I was developing the model, it also involved a lot of piecing together different pieces of information. So obviously we have our sturgeon experts at DD&I who shared a lot of their really hard-earned knowledge with me. So I had this sort of mechanistic structure of how sturgeon behave. So we know such things as adult sturgeon migrate upstream in the spring to spawn, and this migration is triggered by a combination of temperature, and then the spawning is triggered by a water level peak. And in the literature, what I could then do was have a look at other research on the sturgeon and the summaries of different data that have been collected on sturgeon, and really pull out these key parameter measures, such as a temperature range within which spring migration occurs, but also including such things as sturgeon speed and potentially fecundity rates, things like this. All of that is put into the model, essentially summarizing our knowledge of the beluga sturgeon in the Danube River. And so since we have so much information, we also simulate a lot as well. So one big thing that we simulate is the adult migration and spawning. And you can see there in the yellow box all of the different triggers that we're using. These are examples of these sets of rules which determine when migration and spawning occurs. And essentially what you have is within the model is these sturgeon that move according to their speed and whether they've been triggered to migrate, whether they've been triggered to spawn. So we have sturgeon migrating upstream, stopping at key spawning sites, and then migrating back downstream into the Black Sea. We also simulate what their eggs and the young of the year do. So once spawning happens, obviously you have these big collections of eggs. And we can use temperature from the environmental data and from knowledge from the literature to simulate how long it takes for these eggs to hatch. And once we have these young of the year who are then traveling downstream at a speed we've also got from the literature and from research at DD&I, these speeds, we can then simulate how long it takes them to get down to key sites, such as a feeding site where the scientific monitoring occurs. This is this young of the year catch we were talking about earlier. So we have this whole system which really simulates a lot of what is going on with the sturgeon in the Danube river system. But what can we use it to find out, and what did we find out? So firstly, with experiments to test how much each of the parameters influences key times and key events, we determined that the spawning temperature threshold, that's this literature-derived temperature threshold, which really triggers spawning, and then also another threshold that triggers migration, and also the environmental data set location that we use. Remember, there's all these stations down the river, and you could use any of them. They're really the most important parameters that we use for this model. So really picking these very carefully and considering which ones we're going to use will have a big influence over how reliable our predictions are. And there's also an interaction effect, which means that they both sort of boost the effect of the other. So these are really important parameters going forward when we want to actually predict and nowcast when sturgeon are going to be spawning, migrating, etc. We also take the virtual ecologist approach in this to answer this question of the link between young of the year catch and changes in that number year on year and levels of adult population. So this virtual ecologist means we're simulating the catch. We're putting this virtual ecologist there to take the scientific fishing. And then we're also influencing the behavior of the simulation. In this case, we basically enforce an increasing or a stable or a decreasing population of adult sturgeon. So we know both sides and we can see whether they are related to each other. So while the young of the year catch remains a very important measurement to take, unfortunately what we found was there wasn't really a link between this young of the year catch and the adult population. So unfortunately, monitoring young of the year catch year on year and seeing an increasing number of young of the year does not necessarily correlate with an increasing adult population. So we have to find other practical ways of monitoring adults. So that being said, there's still so much more that can be done with the agent-based model, and we'll explain that what has been done in the Nature First project. But just so that everybody knows, we will also have an open source GitHub released when the publication is released very soon. Well, I say very soon scientifically. And if you're interested in working on it, then please do get in touch. But what we're going to focus on for the rest of this webinar is how to make it really useful in the field. And that's where I'm going to hand over to Melanie and Marian to take it forward and to really go beyond this scientific simulation use and really towards where we can use it to optimize scientific monitoring.
Okay. Melanie, we don't hear you. We don't hear nothing.
Thank you. Thank you. I was on mute. Thank you. Okay, I was already talking, but I will start again.
No, it's okay.
So, great, thank you. Thanks, Anna, for handing over to us, to the development team, because we want to really show with this presentation not only the scientific work that's been done, but how we collaborated in this project. And yeah, there was a specific handover moment when Anna had created this model and gotten a lot of value out of it. But to bring that value to our field partner, which is DD&I in this case, the sturgeon researchers, there is kind of like a translation step needed to get this the scientific model into a tool. And I will show you in a second what it looks like, this handover moment. But first, let me introduce you to the developer process. So me and Marian were the developing team. And at the handover, we basically got the task translate this research into a tool, into an interactive tool to visualize what has been done with this model, show some of the inputs and the outputs in a very easy easy way to interact with it. So that was our task, and Marian will come into the picture shortly, but I will start first. And we're going through this process together of some key moments in the developing of this application that we made from the model. So first, the handover from science to a tool. So Anna has created a code base. All of her modeling has happened in a coding environment. And it's a lot of scripts and it may seem a little bit daunting. For us as data scientists, we at least recognize this, but it's still always kind of it takes a good deep dive to understand somebody else's code and to understand what are the key aspects, what do you need to run it, and what comes out, and how can we shape that into a tool. So this is what it looked like at the beginning, us trying to comprehend this code base from Anna. Am I changing slide? Yes. And then we start thinking about what the tool should look like. And at Sensing Clues, we have a bit of experience with this. We have worked with multiple scientists to bring their outcomes, their results into a more interactive tool where users can actually see these results and explore them and have a good visual of what it means. And therefore, make this scientific translation to the public. That is what we're trying to do, or any end user that we have in mind. So this is what we start with: an empty image of a web application, and we're going to fill that in over the course of the rest of the presentation. Just a couple of examples that we have at Sensing Clues, for instance, in the bottom picture, you see, for instance, a habitat map, which is another type of data that we have, and we've put it in a very similar web application to let people explore these habitats. And you have inputs, you can select specific habitats, and you have the output of the map, which is also something that you can explore a bit further. You zoom in, zoom out, that sort of thing. So this is just some examples, and this is what it's going to look like for the Sturgeon application as well. So when we go to the first step, and I've called it a first map, because me and Marian are both GIS developers, which means we're geospatial data engineers, and we'd like to put things on a map because it gives a lot of context. If you have data, it has a lot of data has a spatial component, and putting it on the map gives you a great initial visual of what we're talking about. And in particular, because for us, at least for me, the topic was quite new. Marian already knew a little bit about sturgeons because he's affiliated with DD&I. But we still want to get a good grasp of what is this area, what we're looking at, where are these sturgeons located. So we start, coming back to the design of the tool, we start with the map element, this big square, which is the most important, really. It draws the eye first, so that's also where we started, getting some things on the map. And what we're talking about is elements like the landscape, the Danube River, and some key sites that already Anna has talked about a little bit. So what I'm going to try to do is take elements from Anna's presentation and bring it back. So here you will see the image that she made of the study area. And we're going to translate that into our tool. And I would love for Marian to take it over from me now. So can we hear you, Marian? Are you there?
I think so. I unmute myself.
Great.
Thank you, Melanie. You can start the video. Here we started with the background graphical interface. Using different kind of geographical background, like S3 word imagery, that it's a couple of satellite images, OpenStreetMap, and so on. And we put on these maps the Danube stretch, and you can find here the 5 entrances of the sturgeons into the Danube between in the migration period. So it's Băstroie, Musura branch, Sulina channel, and the last one in the south is the Sfântu Gheorghe arm or branch. And this is the entire Danube that sturgeons uses for the migration in order to spawn and to have little babies. And on this we put also the spawning sites that are potential thought by the specialist in sturgeons, and also together with the wintering sites and that are potential or proved ones. And you can see some information about these points that are made there, and also the young of the year feeding site that they spotted in the Danube. And we have a tool they have developed to select and deselect spawning sites, take into account the potential or the proved status of this kind of spawning sites. You can see now with the green spots that are only the proved one, so the sites that our colleagues from Sturgeon team, they proved that there is a spawning site. And also we can show on the map only the potential one, the sites that they think they are potential to be sites for spawning for the Beluga sturgeons. Thank you. It was just the data that we put on the map for this application. Thank you, Melanie.
Yes, thank you, Marian. So that was the initial view of going from Anna's model to a visual of the study area and some key elements to it. So we continue, and that is with another key moment in the process. So we're trying to crack the code of Anna. We're trying to make sure that we can run it ourselves and can recognize the different modules, different elements. And one of the key moments was that we were talking about what are the inputs for this model and how can we play around with those, and which ones are important. And that's what we're going to talk about now. And it's related to hydro stations, or as Anna called them, environmental stations. So that was a pivotal moment that when we started talking about that. And I just wanted to come back to that this collaboration was really throughout the last year. We've been working together on this, and we tried to inform each other. So we have the scientist. She, even though her work was sort of finished and she's moving, she's doing lots of great other research, we're still in contact to get the most out of this model and have informed development. So not such just us taking over, but we keep in contact. So the developers are there on the left, and then we have the experts on the Sturgeon on the right, and also they were very important. We had to stay in touch to make sure that the tool would represent what they are going to need and what the code has to offer. So we were also a little bit trying to get information from both sides to see how we have to shape this tool. And then coming back to the hydro station, so we found that one of the inputs that was very important. So we're looking at now first again the clean slate of the tool, and we're focusing on the input sections. What are some things that you might want to toggle or change, or that have an effect on the output that is going to be shown on the map? So when we started focusing on that, what we saw already in Anna's presentation is that one of the most important things is the environmental station data. Where are they located, these environmental stations? And we call them hydro stations in our map, because they give water information about water level of the Danube River and water temperature. And this temperature component was also super important, as Anna mentioned. So so we started talking about that, and first me and Marian started making something, but we found out that Anna has used in her model a specific time period of this water data up until 2024, which is when she concluded the research of her model, and she created the model with data from 2024 and backwards. But what is of course really interesting is to make this application quite we like to say near real time, so making it more informed by recent data. So we thought one thing that is important is for us to try to incorporate this environmental data in a more recent way. So not just the data set that Anna had, but keep collecting this environmental data to have a very recent picture. And that is going to be our second video. So I'm going to give the floor back to Marian to tell us about how these hydro stations come into the picture.
Thank you, Melanie. I can start over. The stretch of the entire Danube, Romanian Danube, it's full of hydro station. You can see from the beginning with 0 kilometers till the end, that will be in the western part. It's 1,072 kilometers far from the first one. And this hydro station records the water levels of the Danube and the temperature. And you can select, as you can see on the left side, you can select each station from this 23, and you can see the values, the most recent values of the water temperature. And these data are collected from a website. You can see it on the screen, and it's in Romania. Unfortunately, for the people that are not Romanian speaker, you can select the period that you want. So we try to select from the 1st of the January 2025 and the 31st of May 2025 this year. And we can also select the period as you saw, and on the left side you can select which station do you need data from. And in this case, it's the first one, the Sulina, and you can see all the evolution of the levels, that it's in blue with surface, and the water temperature with a light blue line. And you can choose whatever session you want. And we took this data and put into the model. And in the right side, you can see the source of this is the source from the Galatz Fluvial Lower Danube River Administration. So it's their official data that we use. Thank you very much, Melanie.
Thank you for explaining that and giving the visual of where the data comes from and how we put it into our app. And yes, it's a really important input that, as Anna mentioned, influences the output of the model. So we make it a interactive element that the user, the Sturgeon researcher, can choose which station they want to focus on. And then we go to already the last element that we want to show to you, which is maybe the most important. But this is what we like to show you the road towards. So for us, we had to take. It takes time to develop something like this, especially when you are working together. And we very gradually are building this app. But we're coming now to the really important part, which is the output of the model. So how are we gonna show some of these outputs that could inform the decision making of the people in the field. So another pivotal moment that we had while we were working on this model and we were discussing with Anna is, she has some elements in there that maybe are not directly related to the tool. They're very useful for publications and understanding the Beluga Sturgeon migration as a whole. But what we're trying to achieve with the tool is to get information on there that is useful now in the field for people that are working there. We could skip some elements. So that was a great way, where we were collaborating and coming back to Anna and saying, well, do we need this? No. So she helped us simplify the model and really get down to the code that was necessary to create the outputs that we want. And also, very important, keeping in mind that for the outputs that we want to show, what does the Sturgeon researcher, want to see? What does he need to go into the field and have better ways of collecting his or her data? So always we had many moments during the last period where we showcased what we had and then had discussions about, well, what needs to be added. And in that way, we iteratively end up improving the tool and can probably continue to do so in the future, but we'll come to that. Our template, we're focusing again on some elements that we're going to put on the map that came out of the model. And there's going to be another element that was very important that we found out from our Sturgeon expert that could really help them. So we're having a small element. You're going to see it in a minute because soon I will give Marian the floor. And I try to represent, taking some element from Anna's presentation where she made these simulations of running the model. It's not going to look like this, but the output of these simulations has informed what we are putting on the map, which is related to the sturgeon locations. So then we go to the last video, and this is going to be about the output. So Marian, I'm going to start the video.
Yeah, thank you very much, Melanie. The idea is to have the running model results by pressing the run model, but first of all we have to choose the station that we want to take into account, like let's say Tulcha or other thing to the end one. But for this presentation, we took just Sulina into account, and you can see the most recent data. And we have to press the run model, and the script of Anna will run, and these are the results. Visually, you can see the number of sturgeons, results by in general. You can see where are most of the sturgeon concentrated as a simulation, and then you can have the feeding area that are concentrated in Black Sea, sorry. And also you can have it, but now it's not the case, the wintering results, because we started from the 1st of January, so it's not wintering taken into account. And also results of spawning. You can see the darker is the green, the more sturgeons are there. And you can see in the lower part, it's not so much abundant with sturgeons. And the other part that result is the date of the migration, simulated date, the date of spawning, and also the date of hatching. If you know this date as a manager, as a scientist, you'll be able to be in time in the field in order to take some individuals, to mark them and to release, and hopefully after a couple of years they will come back and spawn, and they will have a healthy population. Thank you very much, Melanie.
Thank you, Marian, for showing that and explaining a bit what the results look like. So I'm going to the last slide, which is, we have this. So maybe what is important to say about this result, it is a simulation. So those heat maps that you see are based on agents from the agent-based model. And Marian also mentioned this, and so the simulation output shows where these sturgeon could be, and what we hope is that researchers have a more informed idea of where they should go and try to find these spawning sites, because these, as you saw in the beginning in the first video, these are potential spawning sites. We're not sure, and we're hoping that if there are resources available, we can now target the resources towards the right places. So this is just a small side note, and we'd like to end with that this tool, as it looks now, is still under development. We're all very keen on continuing to develop this, because there is definitely some elements that we could improve still. Like you saw, for instance, the 3 dates, and the spawning date is now a global average date over the whole region, but it's also possible with the model to make it per spawning site. So elements like that we're definitely going to still improve, and this tool is hopefully going to be used in the field soon. But we're still in talks with the sturgeon expert to make it better, and then hopefully he can start using it and putting it into practice. So we hope it made it. This made it a little bit more clear what we did, how we collaborated together, and what the process was, and how we came to this result of a sturgeon movement simulator. And we're really happy to take questions. So thank you for listening. And I think I already saw one great question in coming by during the presentation, which is if we will make this this application publicly available. So if I would like to address that question, because the end user of this application is the DD&I researchers, the Sturgeon researchers. So it's not going to initially be open to the public, no. And we know also that there's sensitive data in here. So this is really to inform the work of the researcher. So it's going to be an application that you have to log into. This, you need authentication to be able to see it. But we are definitely thinking about maybe ways to make a different view or a subset view which the public can see, so that you can at least share some of these nice visuals also in a broader way. But first we will make sure that the app is ready to be shared with the researcher only. So thank you for that question.
And then Beate Striebel, she has raised her hand. Please unmute yourself and then you can ask the question.
Can you hear me?
Mm-hmm. Perfect.
Hi.
Hi.
First of all, thanks a lot. This is great and amazing. And Anna, you have presented this already in the Danube Sturgeon Task Force meeting a while ago, but this is now really a further development, and it's really interesting to see what's happening. I have a comment and a question. Question is, because you said you will be working further on it, are you interested to also scope if data from Bulgaria, for example, could be integrated in this model? WF Bulgaria holds a couple of monitoring data that could maybe be, because it's the same stretch, so it's not, you know, a different population or a different area. So that would be something, if you're interested, we could explore together. And secondly, I mean, colleagues from Danube Delta National Institute, they will know, we just information for others, we are just started a project called the Monster Project, which is trying to bring together habitat data, existing habitat data, and also population data from the whole Danube stretch. So, and the ICPDR is willing to host a database for this. So this will be a static database again, but the advantage of hosting it in ICPDR is that we will have a neutral, that's the International Commission for the Protection of the Danube River, for those that do not know, that we have a neutral place that can bring data together. So it's not, you know, data just in one institute or in another institute or in one country or another country. So it's a neutral place that brings data together, and can also bring, has a database that is updatable. So that's in I don't know, 2 years when a new project starts, data can be integrated in this database. But again, it's a static thing. So in combination with something that you do in this model, this is like bringing my dreams come true about sturgeon conservation. I think we couldn't really think about more developments on that.
Fantastic. Yeah,
I think we really should connect. Also, Marian from DD&I, I hope you or your colleagues can join the meeting in July, the kickoff meeting for the Monster Project, and we have some opportunities to discuss there. Thanks a lot for this.
Thank you. Yeah, that sounds really, really interesting. Yeah, I mean, I know you say it's static data, but already we're finding from developing a lot of these sort of interactive tools, you know, having that data accessible and having that data out there, such as with, you know, Marian has basically enabled the data from these hydrological measuring stations to be incorporated. And it would be really cool if there was a link to information like that in such a database. I mean, you know, from my work, it's not included in the end result for this migration prediction tool, this migration simulation tool. But in the original agent-based model, we also had some population dynamics as well. But we didn't go forward to sort of include that in the tool because at the moment it was highly theoretical, essentially. But, you know, the more information that we get on sturgeon, the more that can be integrated and taking from this sort of static, as you say, database, but really integrating it into more dynamic tools such as this that that we're developing together. So yeah, it sounds super interesting, and definitely reach out. We'll have our contact details on the final page, and I know you obviously have connections with Didi and I, and we've met before, but yeah, sounds fantastic.
Are there any more questions or thoughts, points you'd like to discuss, ideas? Yes, Beate? Oh, you are still unmute?
Yeah, thank you. Anna, I understood from your model that one of your conclusion was there was no link between the young of the year with adult population, correct? So the number of young of the year does not correspond with the number of adults.
Yeah, so to go a little bit, it's a little bit more nuanced, but essentially what we found was, obviously there are lots of confounding factors, which mean, that we know that the young of the year is not going to be directly correlated, proportionately correlated to the adults. You've got such things as increasing predation, all these things that you might not be able to account for, as well as, the mechanism of catching itself, how you're catching and how it's sort of got this random chance as well. So essentially what we found was really that there was no correlation at all when you had adult sturgeon, which was stable population or an increasing population. But actually when the adult population was decreasing, we saw a corresponding decrease in young of the year. So the problem is we want to find out whether the adult population is decreasing. So, a decreasing number of young of the year could also actually just mean an increasing adult population. It's not, then there's all of these confounding factors. We saw with increasing adult population, in some simulations, we just had essentially random young of the year, maybe stable, maybe decreasing, maybe increasing catches. So it's, in some elements, if there's a decreasing adult population, decreasing young of the year could be linked, but in practice, that really doesn't help us so much. It seems, at least from the simulations, that there are too many confounding factors. But obviously, we can increase the complexity of simulations, increase more parameters, and see whether that's still the case. But yes, from what I did in my experiments, yes.
Thank you.
Thanks.
Then I got a question from Yankees addressed to Stefan. And Stefan, the question is, would you maybe shortly explain how you will be using the model in the praxis, in the field?
The plan is to use the model in Romania, because we did the model before as less sophisticated model we used before to estimate the spawning moment of the Beluga sturgeon in Danube River in order to go in the field and capture the larva and young of the year. But the plan is to extend this usage of the model in the river stretch between Romania and Bulgaria, and also in Serbia, where are still sturgeon population below the dam. Below the dam are anadromous, all four species, but above the dam are also we can find steadless sturgeon. So the plan is to improve the model in the future and to use it and add more data in the model to be better, to make better predictions, and also to study the sturgeon habitats much better, the ones which are on the Bulgarian river side, which are most of them are there, and to prove them, because we successfully prove here some of the habitats in our area, but there are many more in that the river stretch between Romania and Bulgaria. And river, the right bank on the Bulgarian river side, it's more rocky and more suitable for sturgeon spawning. And we identify some of the habitats there, and in the major projects, Bulgaria, Stoyan Mihov also provides some data that did talk about that may be integrated in this model. And some of the habitats we identify overlap with his data, but he provides some data which was not in our database. So we hope that in the future we'll be able to use this model and to identify more sturgeon habitat in the river between Romania and Bulgaria, and also in Serbia, in order to be able to protect the sturgeon population in these areas.
Thank you very much, Stefan, for this information and updates and outlook as well.
Yes.
Maria has raised her hand. Please.
Thank you for the presentation. Yeah, and thanks also for Stefan's comments related to the sturgeon in Serbia as well. I'm curious to know, actually, maybe it will be a funny question. Is there any potential in this kind of tool for the effort from the poaching activities related to, let's say, settlements where we can expect some poaching activities? Because we know that there are particular areas on the Danube stretch where we can expect that poaching activities will happen. And maybe there is also sort of database in WWF. So is there any idea to combine also these effects and impacts and in this program? Because, I mean, seems to me like a good tool also for some expectations related to effort.
Maybe I can start from the data perspective, because this is a great point you raised, and we have had some discussions about that as well with DD&I. There's definitely an opportunity to collect this data and show it on the map, but for the we have some experience maybe with risk mapping, where are the highest risks of poaching. We do need a good amount of data, so it really depends on how much data you have, and this is something we're still figuring out. And I think also the connection to the model is something that I'm not sure about if that's what Anna knows best. But in terms of putting it on the map, for sure, but we need to have a bit more data to make sure that we get these, we like to call it actionable outputs, such as this risk. Where's the risk of poaching highest? We need good quality. But if you have some interesting data sources, then we're happy to know about it. Yeah.
Maybe Stefan can add something
Yes.
first, but I also have something to say afterwards. Yeah.
I'm sorry, Anna.
No problem.
Yes, we use it in the framework of the Nature First project. We use the Sensing Clue app. And with this app, we try to identify when we go in the field, we pinpoint the area with fishing areas, with the fishermen. So, and we are able to do some maps, risk map regarding the where the risk is higher for poaching. It's normal that where the fishermen are fishing, because the sturgeon cannot be fished in everywhere. It's the special place in the river where the bottom is good for fishing. You don't have nothing there to tear off your nets. So we feed this information in the app, and we did some risk map regarding the potential area with higher risk for poaching. But I don't know if this is possible to be used in this application. This depending a lot of the developers, Melanie, Anna, and Marian, if this data can be also used. Thank you.
Definitely. I mean, I would say that this is also kind of the original plans and perspective that we really had for the Sturgeon model. So we kind of realized, obviously, Sturgeon research, there's not really so many models like this out there. So a lot of what I did had to be done from scratch. And anyone who has experience in agent-based models know that they take a real long time to develop and build. So essentially, yeah, I mean, the next steps are really to see what else we can include. And I do think, yeah, as you say, that including this poaching information and risk mapping is really this very informative element, not only for then, predicting times for sturgeon monitoring, but also coming back into this kind of conservation and protection side of things. So yeah, I mean, unfortunately, the Nature First project is coming to an end at the end of August. But we'll see what we can do with this. As always, the case is what funding is available and who can be funded to do it, which is always such a shame when you get so far in a project and you've developed something. But that's also kind of the key of why Marian has been such a crucial part in this partnership between myself, Melanie, and Marian, is that he is working in DD&I. It's not just us as external developers who might not continue partnerships for whatever reasons from funding, but we now really have this person who is an expert in the tool that has been created. And in combination with the knowledge from the Sturgeon team, we kind of hope, even if Melanie and myself can't continue to be involved, that it does continue to be developed. So that is something else and something important to bear in mind going on. I think Marian has his hand up as well to add.
Yes, thank you very much, Anna, for your words. I wanted to complete some words of Melanie. She says something about every kind of data it's available and could be integrated into the model. And I have to say that even point data that are specify how many fishermen are on the stretch of the Danube River, and also, as my colleague Stefan says, that it's good to have prone to say fishing activity, sorry, on the shore of the Danube could be also area that have higher or lower risk for poaching. So we can integrate from point to polygons data into the model. So it's open for all kind of data. But of course, if you want to have reference, geographical reference to the data, you have to have the coordinates for different kind of data. Thank you very much.
Thank you for this very interactive session. Are there last chance for another question or thoughts, Jan Kies?
Not a question, but in addition to discussion on how will this carry on after the project, because the project is now lasting till September and then finishing. But the idea of the project was also to build a platform and also an organizational structure that can sustain these types of activities at a much lower rate than, lower cost than developing this original model. So where this original model has costed probably more than $100,000 or $200,000, the sustainment of this, if you do not account the time of Marian, for example, pushing things forward in your own time, is comparatively very little. You talk about 5,000 to 10,000 euros on an annual basis. You can still keep on developing this. And we also actively work together with the department of Anna, the Wageningen University, where students, like master students, work on projects like this, and they love to work on projects like this, to bring in small steps things further, rather than the big steps that we can take in a project like Nature First. So I'm pretty convinced that we can push this forward for the next few years, at least. If there's a project and we can combine it with a project, things will go faster. But if not, things will go a little bit slower, but steady on.
And I think that brings me to my next slide, Melanie, if you'd like to move to the next one. If you have more questions, or even if you're interested in the model or developing something with us, we have all the information here from the Nature First website to Sensing Clues, DD&I, and also the email addresses of Marian, Anna, Melanie. Please feel free to reach out to us. We will also share the slides with the recording after the event in the next few days, so that you have everything in one place. And then the last thing is our next event on the 25th and on the 26th of June. We will have the Nature First conference in Renen in the Netherlands. So yeah, if you have time and if you're in the area, please join us, and we can also have a talk one-on-one. And having said that, I would like to thank, first of all, Anna, Marian, and Melanie for this wonderful presentation, and also to the audience, to the participants, for your questions and your time. And yeah, from all of us, thanks a lot, and hope to see you soon. Have a lovely afternoon.
Thank you.